I'm waiting a little bit for the experts to arrive.
Anna, I'm already here.
What up, skaters?
Oh gosh.
Is that some reference to the ocean spray dude?
Ooh, maybe.
No, it's because you're cool, Corey, and you ride your skateboard around.
No, I don't do that.
Sure. Anna has pictures of you in Woodstock doing it, so I know they're real.
I don't even walk around Woodstock.
Why not, Corey? It's such a great neighborhood.
Something called COVID.
Oh, well, you can wear masks.
Shelter in place, people.
You can walk around without getting COVID, Corey. The shelter-in-place order for Multnomah County's been lifted.
Oregon County?
For Multnomah County.
Do you know it didn't even exist in most states?
I'm not going to comment on how stupid that is, but you can figure that one out.
All right, I think we can get started. You guys are ready for this fun time. All right. Now, please interrupt me or stop me if anything is not looking right or I'm talking about something that you actually can't see. So hopefully you can see this PowerPoint that I use all the time. Can you confirm?
I can confirm.
Okay, thank you very much. All right, well, we are covering gravity utility design. And I saw that only a few people did the homework, so we can go over that together. And it'll be a good exercise, I think, for us. So I added in some Halloween theme here because October is the best month. Cakes knows what I mean. It's our birthday months. Okay, well, let's get started. So I'm going to start with the safety minute. Let me see if I can actually bring this up. So I clicked, oh yeah. So my safety minute pertains to getting good sleep and how when you have your phone with you before you go to bed and when you wake up, like if you're like just scrolling through your Instagram or your TikTok, as the kids do, myself included, that it's actually really bad for you, and that you're supposed to actually put your phone away for an hour before you go to bed. And I don't know how long you're supposed to wait until you wake up, but I started trying this this week or maybe 2 weeks ago. Like I actually did scroll on my phone when I got up in the morning when I went to bed, and I stopped doing that, and I feel way more awake when I get up in the morning. So I think it's an actual thing. We should probably listen to the experts. So they say that it's bad for your vision and it suppresses melatonin, which, you know, that's one of the things that you take when you can't sleep. And what was the last? There was one little thing that they highlighted, or maybe they didn't. But basically, they said cut off screen time 1 hour before bed. But there's also benefits of cutting it off like just 30 minutes. So I actually recommend doing this. It makes a big difference. That's my safety minute. And now moving on to our homework. So we sent out this homework that said more or less that there's a client, we're saying it's Chipotle. They are tasking you with laying out the gravity utility design for a site or just utility design in general. And you're not really getting paid for this work unless you end up getting the contract. So, we don't like to do that, but these things happen all the time. At my former job at Kimley Horn, I did a ton of like really quick utility exhibits for Raising Cane's, which I'm sure we do a lot for those like a franchise, different franchise companies. So the first question that I have for everybody is, which utilities did you lay out? But wait, I have a poll, I think, but I don't know if I know how to use it in this setting here. Oh, yes, I can do this. Hang on. I'm trying something new here. but I don't know if I can get it to work. Mike, can you get yours to work? 1 second.
I'm on my phone, so
That's okay.
I don't think so.
Let me share this poll. So I made this poll, but I don't like with this setup, it's kind of hard to do. Hang on, sorry guys. Well, whatever. If you did the homework, or let's just say if you are going to do the homework, which utilities would you put on your list? I see Ryan has raised his hand. Go ahead, Ryan.
So the first utilities I looked for is I did water, and then I did sewer, and then I did storm in that order. I just know that water is usually the most temperamental, and you have to kind of go away from other stuff. So I always try to see if I can put that in first, and then especially as a quick thing. And then I kind of looked at where sewer would go, and then I looked at the existing stuff for storm to kind of see where I'm going to tie into that.
Nice. Anybody else want to say if there's anything that Cakes didn't mention, any utilities that you thought of or tried to lay out?
I would say mine were pretty much the same as Ryan's.
Okay. How about gas? Anybody think about laying out gas? Or power? Or communications? So those are also important. Often we're not the person who's actually designing the routing of it, but we definitely have a role in coordinating that. So the list that I came up with, let's see. Oh, sorry, I'll go to this. So then I guess the other piece of it, in addition to the utilities that we lay out, what are some of the questions that, like, if you were given this, and I obviously told you to use the as-builts that we provided, but if you were given this without knowing anything, what are the questions that you would ask? I'll call on Oscar.
Yeah, I was actually about to jump in. Well, good timing on that.
Nice.
I think, especially with incoming survey, I'd probably be interested to know potentially some of the tenants who are around, just to get an idea of what they're drawing in terms of water usage, and then that can maybe help us get a better idea of water line sizes and whatnot. And I think that kind of goes in hand into like what kind of sewer, or I guess like what kind of stuff we can connect to as well. I think that can help, especially when you got several tenants, as you can kind of see on those as-builts that are surrounding the sites. I think that's kind of one of the big ones I looked for right off the bat, and then as well as drainage patterns, I think kind of come home with kind of when you receive a survey.
Nice. Yeah, I think that's great. I think so. I wrote down, or Mike and I kind of came up with these ones where first question is always, at least for myself, is do we have survey? Like, what do we know about what's there? And if we don't have survey, is there as-builts? Which in this case, I'll actually pull this up because I actually think some people might have not had a chance to look at it. So essentially, we have this pad site. The south is a Kmart, and we have as-builts for the Kmart project. So this is that same road. So we know that these are the storm pipes, and then we know that we have sanitary and water. But then the question becomes, where do you lay this stuff out? But so back to the questions, is there city mapping? So sometimes when you're just going completely blind in these scenarios, you don't have survey, you don't have as-builts, can you go on Portland Maps or whichever city's GIS system and try and pull that data, or at least be able to draft it in based on like an aerial? And then the last question, and I think Oscar, you kind of started getting to that, is, or actually I think there's one more. What does the tenant need? What is the use? If it's a restaurant, is that going to need something different than an industrial building? And does the industrial building, they often have loading docks. So just those questions of, what do we need to consider as far as like sanitary, storm, water? although water's not a gravity utility, but anyway. And then what do restaurants typically need? Loading docks. What does the future use require? So that's one thing too, where like, for example, the Portland Meadows jobs, they always have like a provision for a future. They have this spec industrial building, and they'll say, well, we actually want to be able to provide sanitary to all four corners of the building, which is typical, but they're a little bit more intense about it. Because what if someday every corner develops an office? So it's good to know those things, but sometimes we don't know them from day one. But so we talked about this. Which utilities did you show? Water, sanitary, storm, comm, electric, gas. Are there any that I'm missing? I don't think there are, but I don't know. Let me know if I am. All right, so jumping into it, sanitary sewer. So we're going to focus in this session, or in this session, we're going to talk about sanitary and storm, because those are the most specific of the gravity utilities. Power and comm and gas aren't really gravity. They can be whatever depth. But when you are doing a utility plan, those are important to consider because they can conflict with your sanitary or your storm. So anybody want to tell me from the beginning? Oh, Mike has raised his hand. Yes, Mike.
Hey, that worked. I just wanted to, real quick before we jump into this, just a little bit about the kind of conceptual plan. And Anna, if you were going to go back to those, feel free to stop me. But a couple of things, I don't know that we necessarily just went over anyone's actual layouts. But, in this case, we had some existing contours. Any thoughts on if you don't have contours, what does that impact on our potential conceptual utility layout? And I can't see anyone, so maybe I'll just keep going. But if we've got a site where we know we've got sewer and storm, we were able to find some GIS maps, but that show location, but not necessarily grade. Any thoughts on, one of the things we need to be looking at is figuring out high points and low points on the site, not, catch basin locations or things like that, but general, flow of the site. There was storm and sewer on this site. If you look at those as-built, that was probably closer than where you potentially found, depending on how detailed you got. Sewer and storm on the site that were potentially closer than where we may have ended up tying in. And if you don't do a preliminary look at, even just Google Earth and, flow direction of the site, we could be showing something that is likely not feasible because of depth of utilities. So, especially if we don't know the depth of existing sewer or storm, water doesn't really matter because it's not gravity. But if you don't know the depth of sewer and storm, we need to do some background on where is the sewer likely deep enough, or where is the storm likely deep enough. And if we're providing a conceptual utility plan to a client, we need to be giving them, if we don't know that information, we need to point out where that information is coming from or what our assumptions were. Because what we don't want to do is give them something, they take it as working, and then we get survey and we're not even close. That we got to run a sewer line 400 feet down the street to get depth on our line, or something like that. So we need to be looking at and making some good assumptions on where do we think the depth of sewer is, where's the natural drainage pattern, and is it likely that we're going to have depth to actually.
Yeah, those are really good points. I see, Jeff, you have your hand raised as well. Did you want to share something?
I did. just one other thing that we should probably do a quick scan for in the upfront stage is whether or not there's a master plan for utilities. Sometimes we get into a situation where, like, if we took this project for an example, they show a master plan, the city shows a master plan for a water loop through the site, a public water loop, right? That they need for future, or if there's a sanitary extension because there's a future street or something like that. It's kind of rare, but a lot of jurisdictions don't have them readily available, but it is actually something to check if you can in your checklist. And again, all of these depend on how much time you're taking and all that. But I think I've been burned by that before, where I didn't know, for instance, a water line, that there were multiple water line loops shown through a site in their transportation plan, or in their water system master plan. So just another kind of thing to put on your checklist. And usually you'll be able to find it if they have a plan, if it's not just a GIS based for existing, if they have a plan, they usually have the perspective, or future on that plan.
Yeah, that's a really good one. And a lot of the times, like at least in my experience with the Raising Cane's, we get that from the get-go, at least from the developer, or Raising Cane's themselves might have that in their like their kind of due diligence documents. They might have a master plan or a reference to a master plan. Well, actually, I think Mike stopped me at a good point, because I think before I go and dive too far into the actual, here's what we should be doing, let's see what people did from the beginning. So I saw Mike doing the homework. Mike Gillette, I'm going to put you on the spot. Do you want to go over your homework? I can bring it up and you can kind of walk through your thoughts of how you set things. Is that okay?
Yeah.
Okay.
So I started by looking first at where the storm and sanitary connections would be. The first one I looked at was the one closer to the site on the south, but quickly realized that we had a finished floor on the building and we wouldn't, I don't know, I can't see there, but I remember that sanitary line was basically right at finished floor, so wasn't a good candidate for tying into. So then saw up on the north side there that one is like 30 feet lower, so figured that's where my sanitary connection would go. And then the next thing was looking at, you can see those storm catch basins there, and there wasn't any line work on them, but they had the elevations. They had the elevations listed on the side there. And so basically I confirmed on the storm network that, what that elevation was, and just kind of did a rough check of where that crossing would be for the sanitary. And then I looked at the storm connection to our building, and then also using the as-built, you could see from the existing grades there in the as-built that the whole site kind of just sheds north and then kind of goes down the hill, down that road to Beaver Creek Road. So I just threw a little rain garden facility, just drew it in on the low side of the building there, and then had my storm pipe out and then connect to that line in the access road there. I said to throw a new manhole into that connection, and everything, like I said, everything kind of just sheds way off to the north, so it not too concerned about crossing conflicts, since it's not a huge site and we have a lot of grade to work with. And then on water, I think that was kind of the only place that you could connect to water. So if I remember correctly, so I just kind of looked back at like our Chick-fil-A job, because that was kind of a similar style or size building, and so just threw the water in there and took a stab at the size of lines, but yeah.
Thanks, Mike. This is great. This looks a lot like the one I did. So that's the one that was the final version. So this is awesome. Cakes or Caleb, do either of you want to share how you went about it? If you don't, that's okay.
No.
Okay. Oh, Ryan's raising his hand. Okay, go ahead, Ryan.
Okay, so I didn't have quite a lot of time, so I kind of just did a really quick and dirty version of mine. If you want to pull that up, Anna. I didn't look up. I knew there was a sewer. My sewer line basically is the same as Mike's. I think it looks very similar to what he did. I did it dropped a little lower. I went to the parking lot. Maybe that could be avoided. But it didn't kind of wrap around where he did to the upper side. But I figured that's what the sewer is, and we wanted to get that in. But I dropped it a little lower because I noticed that we have a trash enclosure there, and since Anna said the project was a Chipotle, I potentially thought we might need a grease interceptor somewhere too. So I kind of boxed in. I have like a little emulator that where that kind of goes into the trash enclosure in case we need some room for that. I know for some restaurants we've done those in the past, and I didn't know, but if we would need it, but I figured that gives some room. And then for the storm, I looked at where the storm was and looked at the catch basins, and I kind of just mocked in a rough version of where I thought it would be. And I did again. I crossed there, but I didn't really. I knew that we had a pipe there, but I didn't know exactly where we wanted to connect, and I didn't want to. I just kind of was really fastly moving through this, so I didn't check all this stuff and make the calculations. Probably in retrospect, that's usually a better idea, but I was just trying to get a fast layout that was decent and showed. And of course, I mislabeled stuff. Great. No, I didn't. I labeled stuff right. And then finally, I also, the reason why I knew we were connecting up here is because the elevations were below the finished floor. So I just kind of said and I know we're draining to the north on this site, at least with our gravity-based storm network. So I kind of mocked those in there. And then I knew we needed water, and water, with all that there, I didn't want to have water in done. So I just threw a water line going in from that public water easement right there and then going into that thing. I didn't really look a lot about placement with all the stuff in the parking lot, but that's when I probably could have done better, but I was trying to kind of mock up something quickly so we could show something. Does that make sense to everyone?
Yeah. Thanks, Ryan. Sorry, I realized this CAD was a little messed up. I fixed it here once the one that Mike opened. Anyways, no, I think that makes sense. I think it was good to think about the grease interceptor. That was one of our talking points for this. And then I think the storm treatment was a really good add as well, just because of, where your site's going to be, it plays into where you put all your other things. So one of the things I wanted to touch on just with this layout, so here's what the final looked like. It's a little bit busier, but so what Mike showed where he made the assumption that there's a pipe here. This is again kind of what I think Mike or Jeff talked about, that we need to make sure we clarify what we're assuming. So we're saying we're connecting to this existing pipe, but the location is assumed based on as-builts. And then storm pipe coming here. We just threw in some catch basins and some treatment areas. And then for the sanitary, I guess the first question, and this goes to what we're going to go through in the PowerPoint, is how do you set your invert out of the building for sanitary? Anybody want to answer that one? Rule of thumb.
I just set mine 5 feet below the finished floor.
And that's just like a frost depth calculation, or just generally what we end up doing?
I think that's what I saw that we had done on a recent project, and also I think I've been told at one point or another that comes out from the slab like 3 feet down or so. Maybe
6 feet is is probably where you want to be. generally speaking. If you have a bigger building, you might want to do some calcs on lay lengths, but 6 feet for a quick estimate is pretty solid.
Yeah. And so what Corey's talking about with the lay lengths for sanitary sewer, we typically, and I don't know if it's 2% or 1%. I think 2% is more conservative, and especially in a smaller building with smaller pipe, they're going to need to run per plumbing code 2% across the building. So what I'm saying is that you measure the building and you want to get from the furthest corner to where you're going to be serving it, and you run that distance and multiply it by the slope of the pipe to get you to what the minimum amount would be, and then you have to drop it. I usually drop it 1.5 or 2 just to account for a floor drain, and then it running all the way across the building. Is that how you guys would typically do that?
Mhm.
Okay.
I would always account for 2%.
Okay.
Bingo.
Building plumbers do not like go under 2% when they're dealing with their design. So always assume 2%, and yeah, like Anna said, from your basically your tie-in, go straight to the back wall and then over to the furthest point on the building, and that will generally get you basically a depth that you know at any point on the building that they can tie into. That's a fairly conservative estimate.
Plumbing code requires 2. An appeal can get you down to 1. So like Mike's saying, start at 2 and don't go to 1 unless, and if you do, you have to notify people, look, this could be an issue.
Right. Yep. And one thing to note, and this is just from the experience I had in Minnesota, is the frost depth is so deep that pipes usually you're 7 feet below always in Minnesota for sanitary. Even storm it's deeper. But yeah, so that's one thing to note as well. And then another item, and this is I'll touch on this, but another item too is if you're working, like if you have a loading dock or really deep foundations or big foundations or grade beams, you have to think about the depth of the pipe coming out of the building and make sure that you're not, well, ideally we won't have to core through these grade beams or footings to get those out of the building. So that's another kind of coordination piece that comes into play here. So I'll hop over back to the PowerPoint and we can kind of go through. So we talked about invert at the building. And then another thing that is interesting, I don't know that they're necessarily different, because now talking to Mike, I feel like I'm all wrong about what I know. But matching inverts, matching spring line or the center line of the pipe. So typically in a manhole for sanitary sewer, we're going to have a drop. I think the thing that kind of throws me off a little bit about sanitary, or something I don't think about a lot, is matching crowns, because we don't often upsize in sanitary sewer. We're usually just running one size the whole way. But then one of the notes is that when we connect, Mike says he does this typical note on his sheets, but when we connect to a main line and we use a saddle, where the question to you is, where do we match when we use a saddle? Anybody want to answer that one for sanitary sewer? It's only 3 choices. We have crown, we have spring line or center line, and we have invert.
Spring line.
Nice. Great job. So then another question is, and this kind of varies by location, but when are drop manholes required in your guys' experience? When have you seen them? Anybody?
I don't know what a drop manhole is.
I can pull up a quick detail of one. So in my experience for drop manholes, typically they happen more often for sanitary, but Mike did say, hey, Mike, can you mute yourself?
Yep. Sorry.
Drop manholes are required more often for sanitary than storm, but Mike did mention that I think it might be Beaverton, that if you drop more than 4 feet in storm, that you need a drop manhole for a storm, which I have never specified that before. But here's the drop manhole detail. Does somebody want to walk through this? I don't think I'm going to explain this well. Anybody? Corey, do you want to explain drop manholes? I don't think I can actually explain it. I just know you need them if you drop more than 2 feet.
Well, the idea, and I could be wrong on this, I believe the idea is simply that, if you ever need to go and maintain these, you don't want to be in there with a sanitary, 3, 4, 5 feet above the invert. And so you're better off having some sort of structure on the inside or outside that drops that invert down and ties in at what it should be. And you also get kind of less splash and that type of effect.
Nice. I think that.
Hey, Anna.
Yeah.
It's Max. My understanding of the drop manhole is if you have stuff dropping from a distance, whatever distance, say 4 feet, it actually starts to pile up and it creates a barrier to the flow. So if it's solids, so that's why you want to actually keep it flowing in a straight line rather keeping it from piling up and creating a clog. So I think that was the explanation I've heard about the drop manholes.
I'll agree with that too.
Both of those are right. And I'm curious if anybody, I'm looking at these details, I've never done an external drop.
I've not
only
either.
done the internal. So
yeah,
it's interesting. I had never even, I've only done the internal. So the thing that you need to keep in mind if you're doing an internal is that it might require you to upsize the manhole from 48 to a 60.
Okay.
Yeah,
Cool.
the other thing,
learned something.
one thing too, guys, is that on an exterior, if you do an exterior drop or exterior drops, a lot of jurisdictions are not allowing that now, or it takes approval to do that. I've run into that a couple of times here where the thought was to do an exterior, but we ended up doing an interior.
Okay, cool. So how about grease interceptors? So I think Cakes talked about the grease interceptor on the exhibit. So I think where I put mine here is, so since it's a restaurant, the waste from the kitchen area is obviously going to have more grease. So you need, pretty much they're always required for restaurants, a grease interceptor for a separate grease line that comes out of the building and then joins up with the kind of the main line that ties into the system. And then you have a separate waste out for the actual sanitary service for your toilets and stuff. So as far as grease interceptor sizing, how in the past, how have you guys sized grease interceptors?
Typically, this is Max. Typically, you get a letter from whatever business, say Chipotle or Starbucks, and usually they'll specify the size that they require, whether it's internal or external. And yeah, that's what usually I look forward to.
Cool. Cakes, I see your hands raised.
So what I'll do is usually you can look at if depending on what information you're given. Sometimes you're given some information like you're given that they specify which one you're supposed to use. Other times you can go on the Old Castle Vault site is a good resource, and then look at your fixture counts, and then you can kind of calculate a grease interceptor size, and essentially based on the number of fixtures they have in the kitchen and in the restroom, they'll be like, oh, you can approximate, this is the size you probably want. That's usually, I found, a pretty reliable way if you don't have information where you're already specified to give one. So that way you can get a size for which one you're supposed to do. Does that make sense? I'm gonna put my hand down.
Wayne, I see your hands up.
Yeah, I just had one question about the location of grease interceptors. Because sometimes I see them stuffed into landscape areas, but now I see that you have a drivable one. Any comments on that, or is that just a mic thing?
They can be in either. They need to be fairly close to a drive aisle or a drivable surface. Generally, we would want them outside of a drive-through lane because they have to be serviced with basically a vacuum truck. Because when they come in and pump them out or clean them, they need to be serviced by a vehicle. So if they are in landscape, they need to be fairly close to a drive aisle. You generally want them further away from, if you've got an outdoor seating area, you want them away from there because they stink. Even if they're vented, they tend to smell. Some clients want them in landscape because you can hide them a little better, so you don't have the 3 manhole lids sticking up at the surface. But generally, I'll try and put them, out in the parking lot, either, in a parking stall or something like that that's further away from the front door. But you just want to pay attention to the depth of them as you get further away. And the further you put them away from the building, the more parallel sewer piping you're going to have with a separate grease and waste line.
And generally, if you can, you want that to vent, and you want that to vent probably back into the main stack of the building.
Yep.
So the closer you are, the better off you are. In addition, you can only extend the risers on the manhole lids so far. So the further you get away from the building, the deeper it goes, which means you need a vault extension rather than just extending your manholes. And that's for potential. CWS is really particular about that one. So just all things, the closer you can get to the building without disrupting, putting them in drive aisles and just think about where the serviceability of each one of these types of things are. And this would be grease interceptors or oil water separators are kind of in the same boat.
Yeah, that was the next item on the list. And I just wanted to pull this up just so people understand what we're talking about when we say grease interceptor. It's just this vault, more or less, something like this. And then for the vault extension, it's that the top slab, I think, has to be higher up. So is it part of the box that is added on? Is that how it works? Like you just have to extend, or there's an additional piece?
There's a couple ways they can do it. You can actually get basically ring extensions for the vault itself, or they can cast the top slab with a deeper side panel.
Okay. Yep. Okay. So some of the items that we talked about is the vault extension and then venting, which Jeff talked about as well, is that, you want, the closer you are to the building, the better for both of those items. Okay, so sewer sizing. How do we typically go about sizing the sanitary sewer if we're not provided that from somebody? Do you want me to tell you? I can tell you. So this is one that can vary depending on where you are, but in our case in Oregon, there is the Oregon Plumbing Code. So if you haven't gone to the Oregon Plumbing Code before, you can just Google it. I think this one actually might be, this is 2014. I think there's maybe a more recent one, but it's always hard to flip through and it makes noises when I change the page. So I picked this one. But so essentially it goes through a list up here of fixture units. So each of these different plumbing uses, and again, this is something that we typically were given, the size from the MEP a lot of the times, but sometimes, especially when you're doing just a quick calculation, you want to run through and just kind of make an estimate of how many there will need. So there's fixture units based on whether it's private or public. And then based on those fixture units, there is a minimum pipe size. And I think that's size of pipe maximum loading. Yeah. So then it's for the drainage piping, the maximum fixture units is like for a 4-inch is 256. So that's typically the way that I would go about it. Does anybody have any other ways that they would size this?
Just something to point out, that table is based on a 2% slope. We occasionally go less on when we're outside the building, and there's a 0.8 factor. I think that's that footnote 5, if I'm reading that number right. Footnote 5 would require a reduction of your allowable fixture units and unit loading by 80%, or not a reduction by 80%, but a 20% reduction.
Cool.
So keep that in mind. The other thing to keep in mind is a lot of jurisdictions, I believe, have a requirement for commercial projects that your stub into the city system has to be a minimum of 6 inches, regardless of if your unit counts show that a 4-inch works.
Is that a Portland requirement?
I know it's Beaverton.
Jeff, do you know if it's Portland or Corey?
I think 6 inches is minimum for commercial in Portland.
Okay. So this is a quiz question, if anybody would like to answer, when would a sanitary sewer check valve be required? Check valve on a line, sanitary sewer line. This is per plumbing code too. So if you've been studying this late at night, in your free time, you might know.
Reading plumbing code before bed instead of on your phone.
Exactly. That's the moral of the story here. Yeah, there you go.
It's required when the plumber tells you. No,
Good job, Corey.
this comes up all the time, actually, and plumbers are much more aware of it than we are. It's when the upstream manhole, let me get this right. I believe the upstream manhole is higher than the lowest point in your building. Is that right, Mike?
Yeah, it's the upstream public manhole or private manhole on your connection. So if you've got a building connection that ties into a main line, if that next upstream manhole rim is higher than your lowest finished floor, you need to have a check valve on your sewer lateral.
And this one is a pretty easy question, but when would a lift station be required? Anybody want to take a swing at that one?
Just stepping back. Does everybody know what a check valve does?
I think a diagram of some sort would help me conceptualize this a bit better.
It basically allows flow out and does not allow flow in.
Oh yeah.
It's so you're not flooding your building with sanitary water, right?
Exactly.
So it's so that if the city line is, flooding, then it can't flow back up into your building, essentially.
Right.
Yep. If the city line surcharges, then yours would surcharge, but you don't want the city's coming back up into yours.
Yeah.
And you get into that a lot with basements. And so that's why I say, a lot of times the first thing the plumber is doing, he will ask you what the upstream manhole rim is of sewer, because that's the first thing he's checking, whether he needs a check valve or not.
And is that check valve at the building? Sorry, Mike. Or is it part of our line? Where does the check valve go?
I believe literally it is right outside of the building. but it's still within the 3 feet or the 5 feet. I've never called them out on terms of just like when I do the right of way, if the building's right of way tight. But I do think it's coming right outside the building. Mike, if you know, correct me.
Yeah, we had one on. I'm trying to pull it up. We just had ours between the jurisdiction had us put a clean out at the right of way line, which is fairly common. We put ours just between the building and that clean out. So it was like 5 feet out from the building.
If you're right away tight, I don't know. I guess I've never had this. Jeff, do you know? Can that sit in the basement? Or maybe Mike,
Yeah, I believe we've had one inside the building before.
Okay.
It is it is not ideal because on a waistline. And I didn't see. I was looking for that other plan where we had actually had one called out. Did you find a check valve detail? It would look similar to the one we use for like a footing drain or a foundation drain for stormwater. I'm sure a lot of you have seen that detail that we use, where it's got like a flap valve inside of a T, so that when water starts flowing back, it pushes on that valve and shuts it. And you in a sewer scenario, when you've got solids that are flowing through the pipe, they can start to get trapped on that flap valve, and they can cause issues in your sewer line. And if you start to get things plugged on that flapper valve that's inside that check valve, it can start to cause backups on the upstream side of it. So, and if you have to dig that up to maintain it, you don't want it to be inside the building. So I believe they can be, by code, they can be inside the building, but you don't ideally want them there, because if you ever do have to dig it up to maintain it or clean it, you don't want to have to dig up your floor.
All right. Do you want me to share my screen now, Mike?
I think you still are.
Oh, I don't know who's sharing. Somebody else was, or maybe I am. It said my thing was done sharing because somebody else was sharing.
Oh, I don't know who that was. It wasn't me.
Oh, well, whoever.
Oh, yeah.
Thank you. That was nice.
Yeah, that was me. Sorry. When Mike was talking about flappers, I figured, I'd give a visual representation of what a flapper is.
Got it. So, thanks, Max.
Yeah. You're welcome. Got you.
Thanks, Max. Okay, so then when would a lift station be required?
And I might be confusing a lift station with a pump station, but I feel like I was on a project where the only way sanitary was able to connect to a public line was that at the low end of the site, they just had to basically pump it via, I guess, it's kind of like a pump within a manhole situation, and just kind of forced it right back up into the public line. So I don't know if I'm confusing the two, but
No,
that's what
that's exactly it. I think they're the same. For some reason, I always think pump station is stormwater and then lift station is sanitary, but I think they're interchangeable. That's exactly it. When you can't gravity flow from your building to wherever the available connection is, you have to pressurize the system, lift it up, and then force main out. I don't know how much we want to go into lift stations because they can be they are very involved. If you ever have a really huge lift station on your project, I can help you, because I've had to work on like 5 of them at this point, and we usually outsource them to like the ROM tech of the world.
Yeah, just avoid them where you can.
Yep. They're
Amen.
super expensive. The ones on the Meadow sites are, some of them are $400,000. Some of them are close to $1 million. And these are really big stormwater pump stations. Like the sanitary lift stations are pretty small, but yeah, they're very expensive and they're very annoying. And they require a ton of coordination as well. So just avoid them. That's
Hey,
the tip.
Hey Mike, on when you were doing like the preliminary stuff for Bircher, and because on that one we do have a lift station for Storm. Did you, I don't know, did you spend a little more time like trying to figure out roughly how much that? I forget, do we do any preliminary sizing on the lift station, or is that part kind of like in this exercise, if you would have needed a lift station, is that just kind of a, you need one and leave it at that, or would you try to go the next step and put a number on it?
I wouldn't necessarily want to put a number on it from our own standpoint. I mean, we've done enough of them that we're probably able to get in the, certainly something you need to let your clients know. In the case of Bircher, we had a contractor already on board, so it makes it easy to get numbers because you just have them do it. Because they're going to be the ones that are responsible for it in the long run anyways. But certainly if we're doing a concept plan and there's no contractor on board, you definitely want to let your client know that, hey, it looks like we're going to be stuck with no gravity option for storm or sewer or whichever one, and give them a heads up, so that and ask them then at that point, hey, do you want us to reach out to a pump supplier or a contractor and get you some rough numbers, or talk to a few folks around the office that have done them and see if we can find a comparable scenario of similar flows and similar depths and things like that. But yeah, we definitely point it out, and then it warrants further discussion if they want more detailed pricing.
All right, let's move to the next one.
And Anna, you're not sharing right now.
Oh, I'm not? Oh, what have I done? Okay, let me try this again. Is it working now?
Yes.
Okay, thank you. Thank you for telling me. Okay, I've got this terrifying meme. So, storm sizing. I have a little spinning wheel of death, so that's good. That's always a good sign, right? I'm just going to close out of it. Sorry, guys. So, storm sizing. How do we do it?
You give it to Mike G and he takes care of it.
I agree.
What if Mike G is on vacation?
Then you give it to Corey.
IDF curves, yeah, all that good stuff.
In general, though, just a FYI to most, and I know we don't really use these much anymore because Mike has really kind of taken over all that stuff, but there are Excel spreadsheets that you can find, I think in the
I'll pass
Portland
to it.
Shared, yeah.
Yep. Portland Water Resources, and then spreadsheets. And then the one that works is the rational method conveyance. Yeah, it's this one. I'll bring it up so everybody can see
That's
it.
the one.
Ta-da! So if you ever, I don't think we have time to go through what you enter into these things, but a lot of the times you can just make an estimate for your time of concentration. You input your acreage, your runoff coefficient, and that's just based on the type of imperviousness. And then I think you just set your, I'm trying to remember how I normally do this. Oh yeah, you set your slope and then your diameter, and it'll tell you whether or not it is big enough, right? It's your Q over QF that you're looking for the output on.
Yep.
I haven't done this one in a while. Okay. Yeah, so you're just looking to see that, like, how full this is, and what do we shoot for? Is it 0.85 or?
Yeah, I mean, you want to be under 90 for sure. at least for a very preliminary standpoint. And typically this is a little more conservative, or quite a bit more conservative as well. So if you are really close and you're further along, that's probably where you get Mike involved. But for a very preliminary layout, enter an area, a rough, set your values pretty high for impervious, and you'll know kind of, hey, do I need an 8-inch line out of this place, or do I need a 15 or whatever?
Yeah, so this one is helpful. I have actually used this one. It's not too bad, and it like Corey said, it just gives you a quick, gut check. Is this going to work?
Make sure if you're using that spreadsheet to be using the 25-year storm tab. Don't be sizing your pipes based on the 2-year.
Very good point. And then the other item is the design storm, which is based on jurisdiction, kind of what Mike was just talking about. I think it doesn't like my meme. I think it's scared of it, so I'm just going to show you it like this. I don't know if that's true, but so the design storm, so for the city of Portland, I think you can't have it over a foot. I don't even remember what it is for the 25-year. And then the 10-year, it can't be surcharged at all. Is that right? Or I'm wrong? Corey?
I think that's right.
Oh, okay. All right. Okay. And then this is actually a similar point that I previously was talking about, that the roof leader invert, especially when you're working with loading docks and you have your footings and grade beams and things like that, just pay attention to where that's coming out so that you can avoid any issues with that. For storm sewer, we typically match crowns. Unless we can't. And sometimes for like the Portland Meadows job that I'm working on right now, there's been a couple instances where we match the spring line of the pipe. It's not ideal, but when you're constrained by slopes and depths and things, sometimes you just have to do that. And then, like we were talking about earlier, the drop manholes. I've never done one for storm, but apparently they do sometimes happen. Okay. I'll go to this next one then, so that it doesn't slide. Okay, so this one I will let Mike talk about because he's kind of the pro on this, but water quality retrofits.
Yeah, so I guess it's just kind of a question of when you're looking at an existing site where you're doing a redevelopment, and you've made your way through the city codes and got out of doing LID, which a lot of them are pushing for now, but in some retrofit situations you don't have the depth, or the grades don't work, or you can't put landscape islands in the middle of a drive aisle, which is where all the drains are. We need to retrofit with a filter. So in a filter scenario, I guess the question comes down to, is it more preferable to have a filter catch basin or a filter manhole? If you only need, say, a 1 cartridge, or maybe you can use a taller cartridge in a manhole, and a catch basin you have to use a 2 filter. Anyone want to point out the difference of, in a retrofit situation, why you might use one or the other? Anyone have any thoughts?
Wild guesses.
Anyone have a guess? How about?
I was waiting to see if somebody else was going to answer. Catch basins generally are lower drop systems. With a manhole, you need, in the range of minimum of 5 feet from your rim to your invert when you're talking about putting a filter in there. And so the catch basins, pretty much all of the any of the contact bay filter, perk filter, all of those, the catch basins are roughly in like the 2.5 feet of drop from rim to invert. So those are more easily replaceable, or you can replace an existing catch basin with one of those a lot easier because you're not, it's roughly the same drop as a standard catch basin.
Yep. Yeah, so that's exactly right. 'Cause so on a standard trapped catch basin that is, likely out on a parking lot, the pipe coming out of it is probably going to be close to 2 feet deep, in a lot of cases, because you have to have cover. You have to have cover over your pipes anyways. In a
Try like
manhole,
2 inches, Mike.
well, occasionally that can happen, but
On retrofits.
most often your pipe isn't going to be right at the surface. You're going to have some drop to it already. So if you have to retrofit with a manhole and you're placing it in line, you don't have any drop where you're placing your manhole because you've got, you're cutting it into an existing pipe that's of a continuous slope. So you now have to rebuild, possibly several hundred feet of line in order to get 2 feet worth of drop, or 2.3 or 3 feet, or whatever size filter you're using, to get drop through that system. Or you have to install a vault, and you potentially have to now surcharge all of that upstream line for a depth of basically 2.3 feet to get above your filters, which is also not ideal. That causes a lot of maintenance issues. So there may be.
Do jurisdictions generally allow that? You have to, say on Salem, for instance, on one of those ones we were looking at, if that, have you ever had it where you could basically argue it to where there's no other options and we have to do this and they allowed it?
Yeah, we did it. We did it on the first phase down at Willamette Town Center. We didn't really have any catch basin options that were going to work all that well. So we elected to go with a pretty shallow vault, and surcharged quite a bit of it. Wasn't all that different from what the existing system was doing, and it got us the treatment we needed, but it's not ideal from a long-term maintenance standpoint, to have surcharging upstream. So if you're looking at a retrofit, you may want to consider, depending on the size of your retrofit. Obviously, if you're redeveloping the entire site, it might not be as big of a deal to replace a couple hundred feet of line, and do a more efficient vault. But it may be worth, it could be worth doing 2 single filter catch basins as opposed to one manhole in one location, because of how much pipe you may have to rebuild. And obviously, the flatter your pipe on site, the more pipe you got to rebuild. And you could potentially, if you're having to flatten pipes, that could impact your conveyance in your existing system, and cause you to have to upsize, and then you can run into plumbing code issues of going back down to lower size once you're downstream of your vault, or manhole. So certainly worth looking into, even if it may mean an extra catch basin or 2. It may still be more cost effective than a manhole where you got to rebuild a bunch of line.
Also, in general, the catch basins are cheaper just from the system cost itself, cheaper than manholes.
And I'll just say my experience too, especially older sites, even with catch basins, you're probably going to be rebuilding some line.
Yep. Yeah, it's not to say that you're going to meet your drop right away. It's just less pipe generally, than if you got to, find 2.3 feet out of a run of, straight storm line.
Yep.
All right. Clean out spacing for both storm and sanitary. This is per Oregon Plumbing Code. And can anybody tell me what the length is before you need a clean out? Anybody who hasn't answered a question yet? Ryan, Russell, Caleb?
Isn't it 100 feet?
Woo! Good job. You got it.
Nice.
Oscar, I see you raising your hand. Do you want to talk? Or are you just wanting
Oh,
to answer
I was
the...
gonna add on to that answer as well, and I think I remember being shown as well. We would aim for 90 feet because we tend to try to leave some vertical length for however high you need to go for the clean out, rim elevation to the pipe. So I know typically I think we'll tend to like do stretches of 90 feet in terms of linear length, and then allow ourselves 5 to 10 for that vertical drop, and then I think that then allows for you're like making sure you're able to reach the stretches of 100 feet. So,
Yep.
100 feet is definitely.
Exactly. I think I learned that when I first moved here. So the plumbing code does talk about this. I think it was 707. Yep, cleanouts. So location says more than 100 feet. Provide one for every 100 feet. And just like you talked about, we want to be more conservative to provide some wiggle room in that for bends and things like that. I guess more cleanouts. And then the question that is the eternal burning question that I still don't think I figured out is what the actual manhole spacing requirements are on a private site.
And I've got one more on cleanouts.
Oh yeah, sorry, go ahead.
Check that.
Regardless of length, you still need them every 135 degrees of bends.
Oh, I didn't know that. Oh yeah, here, that's what it says here is in a drainage line for each aggregate horizontal change exceeding 135 degrees. Okay.
So that's 345s. Every 345s, you need to have a clean out, even if that length is only 20 feet. So keep that in mind if you're laying them out. And then I think I heard Corey mention if you have really shallow storm lines, this generally doesn't happen on sewer because there's generally not sewer that's that shallow. But if you have really shallow storm lines, where you're having to use potentially, ductile or concrete pipe because of cover issues, you need to be very careful about where your cleanouts are located because they can't fit all of the bends of the cleanout. So the cleanout is typically a Y fitting, and then a 45 that brings it vertical. You can't fit all of those fittings in if your pipe is less than 2 feet deep. There's just not enough physical space to get the fittings and the cap and the lid on it. So if you have really shallow pipes, you need to try and get them such that they're by the 90-foot mark or 100-foot mark. They're at least 2.5 feet deep.
So my manhole spacing question. Typically, I think this is maybe only specific to the big industrial sites where we're running long lengths of private pipe. So I think when you're not, cleanouts make a lot more sense. But when you have bigger pipes and bigger sites, you will have manholes on private sites. And I think plumbing code says one thing. And what was it, Corey, that you said to run with? Was it 400 feet? Yeah, 400. Yeah, so that's what we've been doing and no issues. But I would like someone to answer that for me with like some code section. But for now, I think that's what we've always been doing. So I don't think it's a problem.
So the local jurisdiction will have a public standard
Yep.
in their design standards. If you're in Beaverton and Clean Water Services, they'll have a minimum and or a maximum length before you need a manhole. And public brings in a whole different set of rules of you can't have vertical grade breaks or horizontal grade breaks without a manhole. Whereas on private we don't have that issue, but if you are looking at manholes, a good starting spot might be the local jurisdiction public code. It would probably generally be a little bit more conservative than the plumbing code even.
Yeah, I like that. Okay, and then anything else on manhole spacing, or are we good to go to the conflict checks, which I have another spreadsheet to show on that one.
I think the only other thing on manholes, well, some of this goes into that next one, but is just verify that you actually have the depth for a manhole, and that you've got enough manhole over the top of your pipes. If you've got really big diameter pipe and shallow manholes, you may need to call out a flat top, even though potentially your total manhole may be 7 feet deep. But if you've got a 4-foot diameter pipe, you won't have room for a 4-foot cone on top. So you may have to either call out a shallow cone or a flat top.
That's a good one. I hadn't ever spec'd a flat top manhole prior to working here, and I have now a few times. So that was a learning thing for me.
Hey, Anna, this is Ryan. So that question on the manholes, it actually, the code says 300 feet.
Okay.
It's in chapter 7 of the Oregon Plumbing Code, 719.6, but I will admit, I have never seen this enforced. And Mike or Corey, have you guys seen this enforced? I mean,
no.
No.
Going with 400 then, because
Yeah,
it's a lot more.
I was gonna say, what I've typically seen is if the jurisdiction has like a 400-foot spacing on a public side, it seems like even the private inspectors know that spacing and they stick with it. So, anyways, I just wanted to bring that up in case you guys end up having a not so nice inspector.
Garth.
Who's Garth?
Garth Bentley?
Yep.
Be a not so nice inspector.
He's nice to me. Sometimes.
Okay. Well, I think this might be one of the last points on the manhole conflicts. Yeah. So for storm and sanitary too, but I think less often for sanitary because we're not dealing with bigger size pipes. We have this manhole check spreadsheet, and I think Mike kind of maybe can explain it a little bit better. So just jump in if there's anything that I'm saying incorrectly. But essentially, you can select in this spreadsheet, which is in the spreadsheets water resources folder, you can select the pipe size and material, and then it will input the sure. I hate that it does that. It'll input the core size for you. And then you put in the angle based on like 0 being north. And I actually think it does say to do that. And then it will say to you, and this is what Mike was talking about, that where is it? Mike, do you want to jump in here? I can't remember where the number was that you're supposed to look at. Yeah, okay.
So a couple things here I'll point out. So this cell up here, H2, that's your manhole diameter. So this one was a 60-inch manhole. You can change it to 48, whatever you're using. Like Anna mentioned, select your pipe size. It'll pull the core size from all this data over here based on whatever pipe you select. I do recall that there are a few that for whatever reason the pipe size and the pipe material don't seem to have a core size. So you may have to manually change that or select a different pipe material so you get the right core size. The invert is one you input. So if I were to change this to, I don't know if I can or not, but if you were to change this, what it would do is it would change the calculation between the core holes and the core sizes in your manhole. It would calculate the minimum distance between the holes. And you see this, I believe this spreadsheet was based on ODOT, which requires 12-inch clearance between the cores. So anytime you get a number here that is less than 12 inches, it will say that the check fails, meaning that you don't have enough manhole left between your core holes. So if you've got a lot of, if you have multiple pipes or large diameter pipes or pipes coming in at fairly close angles to each other, it's a good idea to run this check to make sure that we're not showing a hole-to-hole clearance that's 4 inches or 3 inches, because it's not going to be a constructible manhole. There's not enough meat left in the side of that manhole to support it. So what you do is change your inverts, change the angle of the pipes coming in, change the manhole size, or potentially, and we don't do this very often, is add an offset. So generally all of our pipes are shown coming into the center of a manhole. You can do an offset where you're offsetting the center line of the pipe to 6 inches right of center line of manhole. That's what this offset column is. We generally don't do that. It can make your core holes have to be bigger and more difficult to actually core, because they end up going through more of the sidewall of the manhole, which is not a good thing either. So ideally we can design them with no offsets, but this is an important, if you are doing manhole design, this is an important one to check. I think Clean Water Services, if I remember right, their clearance is less than 12. I think I thought they used to require 8 between them, but it may be 10. But anyway, just a good quick check that's a lot faster to do than doing a manhole rollout detail, and something we should be looking at if we're doing manhole design.
All right. So a couple final items to consider, and then we're going to play a little Kahoot game thing. So get your phones ready, but not yet. Okay. So 2 final things to just discuss. Utility crossings, and I think I had a detail. Oh my goodness, I'm going to see if I can find it. But essentially for utility crossings, they're not the same when it's sanitary and storm versus when it's sanitary and water. So whenever you're crossing water, you have to provide these minimum separations. Let's see if I can bring this over. So let's see here. Mike, do you want to talk through this one? I don't know that I know this detail very well.
So this is for a perpendicular crossing, well, or parallel run. This is for the parallel run, actually. When you've got water and sewer running parallel. So you don't ever want to put a water line directly over the top of a sewer line. You generally want your water line above the sewer. In the event that the sewer line leaks, you don't want sewage getting in touch and in contact with a water line. So these different zones show where you can place water lines parallel to sewer based on various clearances. So you can't do anything within 1 feet above the sewer line. Within 5 feet, there's various things that you have to get plumbing code approvals on if you're within 5 feet and more than 18 inches above the sewer. We generally don't want to do that. If you're outside of that and you're 1.5 feet above and outside of between 5 and 10 feet, you generally don't have any issues. Now, public generally still requires a 10-foot outside to outside clearance. This would be more for on-site clearances, if I'm not mistaken. But zone 4, where you're within 10 feet and at or below 18 inches of clearance, you have to be more than 10 feet away. So just these in mind. Generally, if we can stay 10 feet away, we're in good shape regardless. But if you do have scenarios where you've got, really shallow sewer, or have to go deeper for a water line to get under a storm line or something like that, where you are dropping down below that 18-inch separation, horizontal clearances come into play. And then with crossings, there's a few different standards there, about, you want to try and center your water and sewer pipes on the crossing, so you don't have any joints that are directly below or above the water or sewer lines. And sometimes you have to case them with CDF or a more less permeable material than just rock, and you generally always want to try and maintain that 18-inch separation.
And what Mike said on the parallel ones too, make sure you're paying attention skin to skin.
Yeah. Yeah. All those are taken from edge of pipe. Certainly on the outside of the water line.
So the last item is trash enclosures. So this one, from my understanding and my experience, it varies depending on where you are, by jurisdiction, whether the drainage from the trash enclosure has to go to the sanitary, or if it has to go to storm, or if it has to go to both. Mike, do you want to talk about that a little bit, or Corey?
Sure.
Just the different places you've been, what it's like.
Yeah,
Okay.
it depends on the jurisdiction, and a lot of times this can come down to planning codes, which is an odd statement to make when we're talking about utilities. But the reason it comes down to planning codes is if the planning code requires that your trash enclosure be covered, or have a roof on it, then any internal drainage likely has to go to sanitary if the drain is required. So the code sections that require this can come in multiple different locations. Your first bet would be is if it's covered, any drain that's inside there almost guaranteed is going to have to go to sanitary, because it's basically considered inside of a building or inside of an enclosure, and they need that to go to sanitary. Whether you have to have a drain or not can come down to the engineering code. So occasionally there's certain things that you can do to just sheet flow your trash enclosures out, and have them go, even if there's a roof on it, you can sheet flow them out and have them go to your stormwater treatment facility. There's a whole bunch of oddities when it comes to if you're infiltrating water, and how that relates to trash enclosures with regards to UIC registrations. I believe DEQ says that you can drain a trash enclosure to an infiltration facility only if it goes through a bioretention facility, and not through a filter. So if you're not taking trash enclosures to a sewer drain and you have infiltration facilities, just be very cautious about how you're dealing with that water coming out of your trash enclosure. Make sure you're aware of what type of treatment facility that you've got on the site, and whether or not you can directly send that water there, and still be able to get past DEQ regulations. But yeah, generally, oftentimes we don't necessarily want to sheet flow stormwater out of a trash enclosure because it can get pretty nasty, and you end up with residue and streaks of nastiness going across your parking lot. So if you do have a drain in there, just be aware that if you're covered, it's going to be sanitary. And that will require that you have a primer line and a trap and a vent on that drain. And we have a detail in our detail library that shows that. Generally, you'll want to vent your drain to the roof of the trash enclosure. And you need to have a note on your plans to coordinate a primer line with the building plumber. Oftentimes that's going to come off a sink or a toilet or something inside the building, drinking fountain potentially, that will activate when the sink flush or the sink turns on, or the toilet flushes to shoot water into that drain so that it stays full of water, so that we're not getting sewer gas coming out of the trash enclosure.
Anything else? Any questions from anybody? I promised my spooky PowerPoint, so I had to put these really low quality images on it. Well, if there aren't any questions, oh, go ahead.
I think one final thing to think about, generally speaking on these, water's pretty simple because it's, all pressure. But I don't think we pay attention enough to hydrants. So do kind of keep that in mind if you're laying out a site or looking at a site, pay attention to where it, if they're close enough, or if you have a bigger site, if you need a fire loop or private fire hydrants on site. So that's just a kind of something to think about, because those can be some bigger cost items as well.
All right, guys. Well, we are about to play a game that will take about 2 minutes, and then we'll close, but it's a little like quiz. So if you want to, I'm going to click on this and it's going to just give you random names. So if you go join on your phone, I think you want to join on your phone. Oh, wow. Do you guys hear that noise? Oh, good Lord. It's bad. Okay, I had to stop it. Sorry. It was making some very loud noises, but yes. So if you can go to kahoot.it and then type in the game pin. Oh, and so it'll randomly generate a name for you. So it's all anonymous. So if you get anything wrong, you won't be embarrassed. All right. I'm entering in my game pin as well, even though I know the answers.
Is this a rig away, Anna?
A what?
A rig away?
I have no idea what that is. Rig away? Like it's rigged? Is that what you're trying to say? Is everybody in? 1, 2, 3. Oh, keep going. Oh, yeah. These are fun. Wait a couple seconds. I don't know how many are. 1, 2. There's 9 on my screen.
It says we've got 14 in the meeting.
Okay. Well, I think some people, I don't think everybody's like actively. So I'll wait just a minute longer. Speak now or forever hold your peace. Oh, smiling snail. Thank you for joining. I like when you can't see anybody. That's kind of fun. Okay. All right, I'm gonna get started. I got 1 minute left until our time is up. I don't want to keep people too long. So let's go. So on your phone, you'll select the answer. This one is completely based on my own opinion, so choose wisely. 9, 10. One more answer. Wow, you guys did pretty good on that. I agree. Halloween, all of them. They're the best. All right, next question. Magic Ant, great job. Very quick response. Which of the below is not a gravity utility? Wow, that was quick. Good job. Next. When are grease interceptors typically required? And I say typically, just like the most common. Oh my goodness, you guys are so smart. You were listening. This is good. Who's in Magic Ant? Great job. How do we determine stormwater pipe size? This one is kind of a trick question because technically there's more than one right answer, but I didn't want to pay for the premium. So sorry. That's what I wanted the answer to be, but technically, like, it can be these ones, but this is what I was intending it for it to be. So you guys are reading minds. This is great. Wow, Magic Ant. I want to know who you are. Rockstar Ant. Wow. Neck and neck. For stormwater quality retrofits, which type of retrofit is often preferable? 8 answers. Let's see who was listening. Everybody was listening. All right, I think this is the Decisive Bison has the highest answer streak of 5. Wow. That means. Okay, for sanitary sewer connections using a saddle, which pipe elevation do we typically match? Maybe I made these too easy. I think I did, but that was kind of the point. Great job. String line for saddles. And wow, that's close. Last answer. For storm sewer, which pipe elevation do we typically match? Good job. Typically, we match the crown. And that is all that I have for you, this branded. Oh, let's see who won. Jolly Seal, Decisive Bison, and the winner is Magic Ant. Magic Ant, would you like to reveal who you are? Who is it?
I saw all these answers yesterday, so.
It was you, Mike?
Yeah.
You're supposed to try half as hard. Just kidding. Anyway, well, that's all I got for everybody today.
I would have won if it wasn't for, if we would have picked Beetlejuice.
Who's Decisive Bison?
Yeah, who is Indecisive Bison? Is that you, Corey?
No, I was Jolly Seal.
Or Decisive? Oh, Jolly Seal. Who's Decisive Bison?
I'm Decisive Bison.
Wow, great
Intern.
job. Good work. Well,
Mike just couldn't let him win first place, though. Keep him in his place.
Show them who's boss.
oh gosh. All right. Well, if there isn't anything else, thank you guys for your time, and this was fun.
Thanks, Anna. Appreciate it.
Yeah,
Thanks,
this is
Anna.
awesome.
Guys.
Thank you.
Guys.